Good morning, student. Today we are going to discuss about circular queue in data structure. A circular queue is a fundamental data structure that allows elements to be added and removed in a circular manner. It is a linear data structure with a fixed size where the first element is connected to the last element, forming a circular loop. In order to overcome the limitations of linear queue, we are going on for circular queue. The name implies it is circular in nature. Here, the front and rear variables are displayed in the circular movement rather than from left to right. A circular queue is also implemented an array and is conceptually viewed as a circular one. The overflow may occur only when all the locations are filled. When the rear pointer reaches the end, it is made to check the first location. Definition of circular queue. It is a linear data structure that follows the first in, first out principle, similar to standard queue. However, in a circular queue, the element is connected to the first element, forming a circular structure. Circular queues are often represented using an array with the front and rear pointers keeping track of the start and end of the queue. The array is treated as circular with the first and last indices being connected. Advantages of circular queue. Efficient memory utilization, avoid wastage of space. In a linear queue, the available memory can become fragmented, leading to unused space. But circular queues avoid this issue by continuously reusing the same fixed size array. Circular queue make use of the available memory more efficiently by wrapping around the end of the array back to the beginning. That is the efficient way of memory utilization in circular queue. Continuous operation. Circular queues can operate continuously without need to reallocate memory or shift elements, enabling more efficient and uninterrupted processing. Simplified implementation. The circular queue in nature simplifies the implementation of NQ and DQ operations as the front and rear pointers only need to be updated in a circular manner. Disadvantages of circular queue. Implementation complexity. Implementing a circular queue involves more complex logic compared to a linear queue, especially for managing the front and rear position. Fixed size. A circular queue have a fixed maximum size which can limit their flexibility and lead to wasted memory. If the actual usage is less than the allocated size, inefficient deletion of queue. Dequeuing elements from a circular queue can be less efficient than a linear queue as it requires adjusting the front pointer to maintain the circular structure. Applications of circular queue. Circular queue can be used in operating systems, multimedia streaming, simulation, and modeling. The queue is used in the scheduling of jobs by a processor in a time sharing system. A CPU associated with memory resources are to be shared by n number of users. The sharing of processor and memory resources is done by allocating a definite time slice of the processor's attention on the users and in round robin fashion. In such a system, the users are unaware of the presence of other users and are led to believe that their job receives the unindividual attention of the CPU. However, to keep track of the jobs initiated by the users, the processor relies on a queue data structure recording the active user. Then multimedia streaming. Circular queues are employed in multimedia streaming applications to buffer data, ensuring a smooth and uninterrupted playback experience. Simulation and modeling. Circular queues are utilized in simulation and modeling algorithms to represent cyclic processes such as traffic patterns or resource allocation. Network routing. Circular queues are used in network routers and switches to manage the flow of data packets, ensuring efficient and fair network traffic management. Implementation of circular queue. The circular queue can be implemented in the three stages of processing, overview, representation, memory usage. In a circular queue is a data structure that represents a queue with a fixed size where the last element is connected to the first element. That is the key point about the circular queue. The last element is connected to the first element. The representation, the circular queue is typically represented using an array with two pointers, front and rear, to keep track of the first and last elements. Memory usage, circular queue efficiently uses the available memory by reusing the unused spaces, making it more memory efficient than a linear queue. The implementation of a circular queue involves managing the front and rear pointers, ensuring that the queue wraps around the array when the end is reached. This allows for efficient insertion and deletion operation, making it a versatile data structure for various applications. Primitive operations on circular queue. The circular movement of front and rear variables implemented using mod function, which is cyclical in nature. NQ operation, add element to rear. To NQ an element, the element is added to the rear of the circular queue. Update rear pointer. After adding the element, the rear pointer is moved to the next position following the circular nature of the data structure. Then check for overflow. Before enqueuing, the implementation checks if the queue is full. If so, the operation is aborted to prevent data loss. DQ operation. Retrieve, remove the element from the front of the queue. Advance, move the front pointer to the next position. Decrement, decrease the number of elements in the queue. The DQ operation in a circular queue involves retrieving the element at the front of the queue, advancing the front pointer to the next position, and decreasing the number of elements in the queue. This ensures that the queue maintains its first in, first out principle structure and allows for efficient and removal of elements from the front of the data structure. Front and rear pointers. The front pointer in a circular queue indicates the position of the first element in the queue. It is used to DQ elements from the front of the queue. The front pointer and rear pointer, a linear, as in linear queues, front points to a position which is one less than the actual front of the circular queue. Both front and rear are initialized to 0. The rear pointer in a circular queue indicates the position of the last element in the queue. It is used to NQ new elements at the rear of the queue. Pointer movement. As elements are NQ'd and DQ'd, the front and rear pointers move around the circular queue to maintain the correct position of the queue. A circular queue is typically represented using an array data structure. The array has a fixed size and elements are added and removed in a circular fashion, with the head and the tail pointers wrapping around to the beginning of the array when they reach at the end. Then circular queue initialization, memory allocation, front and rear position, initial values. The circular queue is initialized by allocating a fixed size array to store the element. The circular queue uses two pointers, front and rear, to keep track of the start and end of the queue. Initial values, the front and rear pointers are typically initialized to -1 or 0 depending on the implementation to indicate an empty queue. Circular queue insertion. NQ operation, updating pointers, checking for overflow. To insert an element into the circular queue, we perform the NQ operation. This involves adding the new element to the rear of the queue. We perform the NQ operation. This involves adding the new element to the rear of the queue first. Then, if there is space available, we update the rear pointer to the new position and insert the element. We then increment the rear pointer, wrapping around to the beginning if necessary. Before inserting the element, we need to check if the queue is full. This is to ensure we don't exceed the maximum capacity of the queue. Circular queue deletion, remove from front, update pointers, check underflow. In a insertion, insert from rear, update pointer, insert into rear, update pointers, check overflow. Here, remove front, update pointers, check underflow. Remove the element at the front of the queue, increment the front pointer to the next position. Ensure the queue is not empty before deleting. The deletion operation in a circular queue involves removing the element at the front of the queue. To do this, we first check if the queue is not empty. Whenever you are going to delete from the circular queue, we first check if the queue is not empty. If it is not empty, we remove the front element by incrementing the front pointer to the next position in the circular buffer. This ensures the queue maintains its first in, first out order. Circular queue overflow. Circular queue has a fixed size determined by the length of the underlying array. When the queue becomes full, attempting to NQ an additional element results in a circular queue overflow. This occurs when the rear pointer reaches the end of the array and there are no more empty slots available to add new elements. The circular queue's capacity is completely exhausted. That means that the circular queue comes in overflow. The remaining space 0, no more empty slots available for new NQ operations. Circular queue underflow. The circular queue underflow occurs when an attempt is made to dequeue an element from an empty circular queue. This can happen when the queue is completely empty or when the front and rear pointers are equal, indicating that the queue is full. Underflow can lead to undefined behavior such as returning an error or crashing the program. To prevent underflow, it is important to check the status of the queue before attempting any dequeue operations. A circular queue is also implemented as array and is conceptually viewed as a circular one. The overflow occurs only when all the locations are filled. The overflow occurs only when all the locations are filled. When the rear pointer reaches the end, it is made to check the first location. That is, when the rear pointer reaches the end, it is made to check the first location. Here, the front and rear variables are displayed in the circular movement rather than from left to right. A front points to a position which is one less than the actual front of the circular queue. Both front and rear are initialized to 0. Procedure to insert a circular queue. Rear is equal to rear plus 1 mod n. If front is equal to rear, then call circular queue full. Retract rear pointer to the old value. And circular queue rear is equal to item end insert circular queue. Procedure to delete from the circular queue front and rear comma n comma item. If front is equal to rear, then call circular queue empty. Front is equal to front plus 1 mod n. Item is equal to circular queue of front end insert circular queue. Thank you.